How you going, guys? Curtis from Cutting Edge Engineering. So today we are going to be making a new set of precision V-blocks for our milling machine. So I use V-blocks quite a lot when it comes to setting up the milling machine in order to do certain features on a lot of the bigger pins we're making these days. Not only do we use the V-blocks for pins, we also use it for shafts that need keyways and stuff like that milled into them. But I've been having a lot of problems with the cast iron V-blocks that you can buy from the different tooling suppliers around Australia. And the problem with those is they are just not heavy duty enough for the work that I'm doing. The cast iron just doesn't put up with the amount of weight that's sitting on them. Some of the pins that we have been making recently are up to 500 kilos per pin. So they are quite heavy, and them sitting in a standard set of cast iron V-blocks, once you've clamped them down, I've noticed that one of my V-blocks has actually formed a crack on the inside of the V. So that's problem one. Problem two is the 90-degree angle of the V. They're just not wide enough at the top in order to hold all the different size materials that we use. So an 80mm pin fits really well in the V-block. It is nicely supported and it is secured once it is tied down. But then we step it up to a 150mm pin, which is very common in here, and it point loads the top of the V-block. But then we get pins up to 200mm in diameter and they just don't fit in the block at all. They're not supported. When you do try and clamp a pin down that size, it's quite sizable, so you do put a bit of weight on it. It point loads the top of the V-block, which then opens up the block and forces a crack to occur down in the middle of the V. So I did have a set of 300mm V-blocks for doing the bigger diameter stuff, but they are now in the bin. When I was milling the groove, I did notice one end of the job was getting loose, and I actually found a crack through the bottom of the V, and the job was starting to move around in the machine. And the issue with the bigger V-blocks is not only do they get wider and deeper, they also get a lot taller. And when they get taller, that eliminates head height between the bed and the head of the machine. And problem three, we're not always just machining one pin. It's always a batch of pins for a certain machine. And in that batch, the pins will be different diameters, different lengths, and have different features like grease grooves being milled into them for grease to travel down the pin while it's in operation, or it could be a hole through the pin for a retaining bolt, or a hole into the pin to allow grease through it. And the problem with that means multiple setups in order to achieve accuracy on the job. With a standard V-block, you do need to dial them in every time you change the setup, and that's where there is a lot of time wasted on the job. So we're going to make our own, which are going to be very strong, they're going to be very precise, they're going to accommodate the different diameter pins we do, and they're going to allow fast, easy setups. Our V-blocks are going to be made out of solid high tensile plate. They are 120mm tall, which makes them very low profile, and they are 250mm wide, so we get massive support over the bed. So a 90-degree V-block, they are more suited to round materials and square materials in order to hold everything so it's nice and true. We have actually changed the angle of the V. So rather than it be a standard 90-degree V, these are now 120 degrees, which will offer a lot more support and strength for doing our large and heavy pins. So I've got a bit of work to do to these. I've got some milling to do, some facing, I've got to cut a slot through the base, and I need to drill some holes. So let's get on to it. Damn it. So I was about to set my V-blocks up so I can then start the milling, and my vices don't open wide enough to hold both parts in the one setup. Ideally, you do them together because they are going to be a matched pair. I am going to take one of the jaws off the clamping part of the vise so I can then fit them in. I will put a piece of sacrificial material in there so I don't damage the face of the vise, and that means we'll be able to do two in one setup to keep as much precision as possible. So I've got them set up. The first thing I need to do, I need to mill the top of the V-block down to give me a parallel surface for when I turn them over to then machine the bottom side of the V-block. So I've faced the bottom of the V-blocks off, that looks really good. I am going to come down on each end and just mill a true reference area so then I can find the center of the block, and then it's there for future setups. If I ever need to use a straight edge or a square to align the blocks to the bed, it's always good to have a true area to go back to. Then after that, we're going to mill the slot through the center of the V-block in order to put our piece of key steel to align the V-blocks into the bed. Now that we've got that 16mm slot machined, what I need to do is drill and tap the 2 holes in each block to retain the piece of key steel that is going to be used to align the blocks into the bed. Righto, so I'm about to drill the 4 holes through the V-blocks that we'll be using to attach the V-blocks onto the table. They will go down into the T-slots and then be clamped into place. If you're going to do a project like this, make sure you check that your table spacings for your T-slots are accurate, because on my table, the 3 T-slots are not evenly spaced apart. Between the T-slot centers, there is a 2.5mm difference. If you don't check those sort of things out before you do this, you could end up having a job that doesn't fit. Righto guys, so we've got the bottom of the V-blocks completed. We have it machined true. We have the slot machined in for our key steel. We have the 4 bolt holes drilled and tapped that hold the key steels in place. And we've got the 4 holes drilled that will hold the V-blocks to the table. What I need to do now is flip them over, and we're going to counterbore those 13mm holes I just drilled so the socket head cap screw can go into the V-block when it is being tightened down onto the bed of the machine. So we've got those holes bored to depth now. I still need to machine the faces and cut a relief through the center of the V, but I'm not going to do that while it's set up in the vices. I do want to clamp it down on top of the bed, but before I can do that, I need to machine up the keys that fit in the bottom of the V blocks.
Lay down. Roll over. Good boy.
So we've got our V-blocks bolted down to the bed of the machine. So we've used our key steel to align the blocks with the T-slots in the table. So now everything should be running nice and straight. What I need to do now, I'm going to put a 12mm wide relief in the bottom of the V. So then when I go and cut the faces of the V-block, I've got somewhere to run the cutter into where it's not going to be interfering with itself. So ideally I would use a big shell mill in order to clean those faces up before I then fly cut them. Unfortunately, my largest shell mill for this machine is only 125mm and across that face is 130. So rather than do two different setups and alter things to try and make this work, I'm actually going to use a boring head which I've sort of converted into a fly cutter. So I will use that to do those faces and just take it real steady on it. So we've got the first side faced. What I'm going to do now, I am going to flip the blocks around in the machine so I don't have to change the setup on where the head is. Even though the T-slots in the table don't share the same centers, they are slightly different by about 2mm. There is enough room in the T-slots and around the T-nuts in order for us to still be able to bolt down our V-blocks into the table. Righto guys, so that is our V-blocks now completed. Considering they came from a flame cut part, they turned out really well. I'm not going to go around all the surfaces and machine them down. It doesn't really achieve anything. But where they are now, they've got the key steel machined through the bottom so they align back into the bed. We have the bolt holes that go through them to then tie them down to the bed. And we have the important faces machined to a nice surface finish so everything can be set up very quickly and very easily. And we're going to show you how quick and easy they are to set up now. Righto guys, so those V-blocks worked exactly the way I hoped they would. The gauge didn't even move 0.01 of a mil, and I don't even think bananas measure that low. This is going to make life so much easier for setting up these multiple pins that we do. We can simply slide the V-blocks up and down the bed to suit what length of pin we're doing. They're fast and easy to set up, and they are as solid as a rock. So to get a heavy duty set of cast iron V-blocks, they're going to cost you nearly $1,000 to get a decent set, but they still limit you for your heights, and you still need to go through the process of setting them up for each individual job. Where what I have here, this cost me about $150 in material and a couple of hours of time. Now I have myself a super heavy duty set of V-blocks that are already dialed in and will be able to handle any amount of weight I put on them, and it's just going to save so much time for future setups. So that's how I made our custom heavy duty V-blocks. Thanks for watching. Righto, so we've got the bottom of the V-box. Righto, so we've got the bottom. Righto, so we've got the bottom of the V-blocks complete. What? What?
The train.
Oh, right.
Do you want to lean more over there?
Oh, okay. I'm just gonna start again. So, fuck me. We've just got a lot of work to do. Let's just do it.
Okay.
Make it all the way through. I can't see shit.
It looked like it did.
Everyone's walking around something fucking chronic. No, that isn't fucking right. Whoa.
How much is left in there?
Hopefully enough.
Wow, that's shiny. Wait, you hold it still. Oh my goodness.
It's very hot. Oh, you son of a... I'll just go in the right direction. Considering they came from a flame cut part and we managed to... So because they were...
Wow, this is so good.
You're amazing. Ready? Let's just do this. One take. Ready?
Yeah.
Right, so even though... So there is enough clearance in the T-slots in the table for the T-nuts to move left and right. There is enough clearance... I'm just going to say this. Right, ready?
Yeah.
Right, so even though the tape... So to have a heavy setting... I just can't get the words out.
Oh, I can tell.
Right, you ready? I think I got this.
All right, let's see.
Are you fucking ready?
I'm ready.
One take.
Okay, sure.
Right. For $150 worth of material and a couple of hours of my time, at $150 in material and a couple of hours of my time to make them, but I'm going to make that back. So for $150 in material and a couple of hours in my time to... and it's just going to save so much time for future setups.
Okay.
What?
Now what?
Thanks for watching.
Oi, sit.